Perfect memories scattered all around the floor. Reaching for the phone, cause I can't fight it anymore. And I wonder if I ever cross your mind. For me, it happens all the time. Don't stop going south. Cause they'll let you play music real damn loud. Don't stop heading south. 'Cause they won't understand the words that are pouring from your mouth. And they wanna cowboy on my horse, riding out into the sunset. If that's the kind of love you wanna wait for, hold on, my girl, I ain't there yet. I've seen heaven without dying, met the devil without trying. Ain't gold seen the one to talk to me. But I'm all out of luck now, and my dreams aren't worth a fuck. How it's tough trying to land on my feet when.
All right. Welcome back, everyone, to another day, another stream, another exploit. Today, we'll be going back and doing some more TryHackMe just to warm up, get ourselves moving. Then we'll be jumping right back into those exploits that we got running yesterday. I was having a lot of fun with those. They were a little tricky, but I'm looking forward to trying it again. So, today I figured we can start with this specific try hack me called compiled. And I think what we're going to have to do is decompile it to try and find the key. So here's the room. And yeah, let's go ahead and get started. All right. So we'll join the room, and this will allow us to download the task files. Download the files and get started. The binary can also be found on the attack box inside the root rooms compiled directory. The binary will not execute, but you don't need that to solve the challenge. So let's go ahead and download that. And it is a compiled file. All right. And you can go ahead and switch over to our Kali. I think today is going to be a little bit tough on my internet. It seems to be struggling quite a bit. So if there's a delay or a lag, have mercy. Let's see. But I got it as best as I could get it. Go ahead and set up our Kelly. I think what we're going to have to do for this one is throw it into Deirdre. I have some experience with that. Not a lot. So we'll both be learning today. Now that that's in there, we can go ahead and stop sharing that. Switch over to our tally. All right. Bring up our terminal. And I think you will go ahead and go to our documents, our projects, pick rooms, make a new directory, call it compiled. Go ahead and open that. Oh. I already downloaded and went over this file. Let's also open up code so we can take notes. We're going to need this later. All right. Notes.txt. So the hint that the site, that the room gives us says, strings can only help you so far. Let's go ahead and kick that off, and we'll see what we get back. All right. F-Lite, TNC end, IO standard in, a lot of weird stuff. We have correct. Try again. Do you even CTF? And that's it. This looks interesting. Oh, wait, what was that? Frame dummy, completed.0. And a bunch of interesting stuff. I think we'll go ahead and open this up in Deirdre. If I can remember how to spell Deirdre. Oh, tell me I don't have it. All right, we're going to go ahead and install Deirdre. Ah, man. This is going to be a rough one. I can tell that my bit rate is like barely a 1,000. We've lost half the frames, apparently. Just 55%. Anyways, now is a great time to talk about our sponsor. Just kidding, I don't have a sponsor yet. But I would really appreciate anyone and everyone to follow me on Twitch. We're so close to becoming affiliate. Then we can start doing some really cool hacking stuff. Maybe even some physical, as long as it's somewhat legal. All right. So for those that don't know, Deirdre is a decompiler, and it will help us sort of walk through what this binary is. In the meantime, we could also try and run this. I'm interested. So ls chmod plus x compiled. So now we should be able to run this. Password. LOL. Nope. That's feels weird not having the music in the background. There we go. All right. What's another way we can walk through this? We can try GDB. Didn't we just use this yesterday? Is it GBE? No. Yeah, I guess we'll want to install that too. Oh, right. That's a lot. Unless we're still downloading and updating through Geardra. Yeah, so I was trying to decide what we're going to do today. I'm glad we were able to finish the last exercise, but there's so many more exercises in that exploit kit, so I'm excited to get back to that. Maybe we'll do a full CTF this week, if things go all right. Wait, I know. Right, now that we have that installed and running, let's just go ahead and install this too. Don't crash out on me. Oh, I love that. All right. Deirdre, go ahead and spin that up. Yeah, I agree, and embed all that immediately, or later in the past. Good. New project. Filed. And we can go ahead and import a file. Documents, projects, wounds, filed. Oh, it's bad. Ooh, that's not good. Yeah. We're gonna go ahead and analyze this. While that's working, let me see if I can do anything different for the internet. Seems to be lagging me real bad. We'll go ahead and try something anyways. I'll be right back. All right. Any better? Or are we actually worse? Wow, we are struggling. Well, let's just keep powering through. I think let's try our best way forward. Okay. So with Deirdre, we can see a bunch of the file. This is the program tree, symbol tree. We can look at the functions. There we go. Main, always a good place to start. You can see some of the decompiled code. So it's a character, buffer 32, F-write password, scan, do even CTF. Well, I'll try again. If string copy, string compare, -1 is less than I variable. String compare that to that. Return 0. Is it this as the password? It's worth a shot, right? Let's go ahead and paste that. Do you even CTF? Yeah. Okay. I think we're gonna have to start walking it through. Here's the collect. I can see some of the assembly code here trying to figure out. Call string compare. Funct int. This is an interesting handle. String compare. So if -1 is less than the I variable and end variable 1 is equal to the string compare that, this being less than 1, try again. So this is what we have to try and figure out. Because our I-var L is what's being written, right? It's DSL handle. Okay. Oh. Let's go ahead and try and look up what DSO handle is. Wait. It's a guard that is used to identify dynamic shared objects during global destruction. All right. Boom. Do we try it? Is it saying if the string is equal to that named? So if I type in, oop, underscore DSO handled. We have our character. String compare I've already. I'm not sure. Let's see what happens if we try and overflow. Now, even percent as CTF. That instruction contains so here. Okay. What is that %s doing there? Is that going to cause an issue? So if we type in do you even %s CTF? Really? I'm not sure about this one. Do you even? Hello? That was weird. Do you even CTF? Okay. So this will trigger this %s. So if we do this in Marrow, if we type in the DSO handle, you even underscore DSO handle. We're making it into the first part, but it's not. What if I don't know. I thought maybe putting something in between the two might help us. Yeah, this stream's gonna be rough today, buddy. That's okay. Whenever the weather's super bad where I'm at, my internet just decides to die. It's awful. So I apologize in advance for all the lag and any issues you guys are having trying to watch. So let's try this GDB compiled. So that's going to load our program into here. So help, type apropos word to search for commands related to word. Read symbols. Right. So it prints out the new even new lines. Makes it normally. Alright. So can we put a break on string compare? Okay. Then if we run this, we put our do you even. Okay. We hit the break at this memory location. Oh, can we just hit stamp? Don't you just say I could? What are you doing? Or working on TryHackMe will to cloud. Long night. But the chat should at least come through. So we can continue. It's the breakpoint again. Oh, because we're hitting this compare twice. And it's looking for a name the second time. Is this 3 levels of entry? So is it looking for, do you even CTF to get into the first one? And then you have to switch the value that you input to be DSO handle. And then once you do that, you need to rewrite it to be a nit for the last time? I think that's what it's saying. Let's try that. So we have do you even to start, and we'll do DSO handle, and then we'll finish with CTF. Yep. Let's pull this into our notes. And break it up a little bit. Because there's 2 checks being done on that string compare. How, I don't know. We should look into what that scanf does. Do we try just putting in this? And we'll score it. Yeah. I'm at a loss. You even DSO handle CTF. So handle. Yep. Do even. No. So even, and then can we try and be on it? You even. Okay. You even. You even a nip? What? Okay. So variable one. Let's look at this version. When we do our write %s CTF, so it's still allowing us to write to local 28. And since this one's rewriting iBar with this string compare for init, And then I guess we get the correct answer. We're using this %s. See if answer format is a bunch of stars underscore 1, 2, 3, 4. So I think it means do you even underscore a name. Let's go ahead and switch up that. And we'll submit and see what happens. All right, we got it. That was pretty easy. I'm still confused, but we got it. All right. I think we can go ahead and jump back to working on some of our challenges for the exploit. I don't think they need to save them anymore. We'll save the notes anyways. Okay. Great. Yes. We did wise guy. Our exploit boom. And then all we have to do is just boop. Bring that over there. Exploit. Education. I think we left off here. Was it stack 2? Right, it was stack 2 because we needed to exploit the environment variable. Ah. We'll get started with this one. Put that in the background. User at, what was that command? That's something that actually should be in my notes. Something simple. -p 2222. User and local paste. User, there we go. Now we can go ahead and take a look at some of the source code. C, DNT opt, Phoenix, AMD, and stack code. I would say that directly. There we go. So let's see what the joke of the day is for today. The aim is to change the contents of the change me variable to this. When does a joke become a dad joke? When it becomes apparent. When it's fully grown up. Grown up. Oh. It got me twice. Alright. Define better. Welcome to level name brought to you by blah blah blah. We get our characters using the gets. Complete level. Congratulations, you finished. Well done, and we exit. We have our main function. Same structure we've been messing around with. Print a string. Local.fp equals null. Get the buffer. Leave locals fp. Print calling function pointer at p. Flush. Else the pointer remains unmodified. Then look next time. And then we exit. So let's execute our stack 3. All right. So just wait here. Let's overflow the buffer. We see we're at 73. I believe that is the hex 4 S. Hex and our character. There we go. Okay. So similar to what we were doing yesterday, we're gonna have to figure out what the characters are to get to the proper address here, which is that I think that's the character return new line tab new line. Do we still have that environment variable set? No, because we had to restart our box. So what we can do is clear the screen. I'm gonna bring up CyberChef again. Just, it seemed like it's been so helpful. So we have 0D, 0A, 09, 0A. I'm pretty sure that's the exact thing we want. So from hex to decimal, just because that's been nice for me. 10 or 13, 10, 9, 10. Hi. And when we look at the table, yep, it's -r, then it's /n, /t, /n. So if we go and run our stack, can we just do /r, /n, /t, /n? We're going to have to do that a lot. And we might have to do, no, it should be all right. Because it's taking the direct input, unlike the environment variable from yesterday. So if we go ahead and paste that a few dozen times, And we got a seg fault. 6C, 5C, 7-4, 5C, 6C, 5C. And yeah, it's doing that again. Me. One, two, three, four, five. 1, 2, 3, 4, 5, 6, 8, 9. And once we hit 9, that's when it starts. Change. We want to change it to this. When you look at that, it's this. And when we look at this, it's that. Do we need the quotes in there too? /r, /n, /t, and then / and again. See if this helps us. The T5, C, 7, 2, to map this again. Need to try one quote, /r, /n, /t, /n. Oops. All right, one more time. It's gusto. I think we'll do the $, /r, /n, /t, /n. Let's see what happens when we fill that up. Still getting this wild address. So when we put that into our CyberChef, we're getting these values out instead of the ones that we actually want. Space, into space, into space, into space, into space. Here we go. Then when we look that up again, yeah, it's the exact same issue we were having yesterday, I think. 110. Backspace. Oh, wait, no. No, wait, no, that's right. No, that's octal. Ah, boy. Decimal is what we want. So we go down to 100, go down to 10, which I think is going to be There's our N92. Let's see there. The one 16, 92, 110, 192, 114, 92. It's 114. There's our R. So it's not executing like we were having the problem with last time. I think, if I remember, we had to do the $, jar, T/N. Let's try this pattern. See if we're able to. Still not working. I can get this to just do /R. Just give me a different address than this one. I'd be happy. So we know what those characters are. Is there just a simple memory location to ASCII converter? Sir. All right. But to type in raw ASCII characters into your terminal, you have to first press Control-Shift-U and then the hex number, like 05, and then press Enter to confirm the ASCII character. To make life simple as possible, I use CyberChef to convert as much as the addresses to typable ASCII, and then I fill in the rest by hand. Because x86 is low endian, the address has to be byte by byte as ASCII. We will fill the buffer with A's, then to start entering the desired return address, which consists of regular ASCII G and @ symbols. 05s and 0s have been typed into the keyboard technique. Let's try this Control-Shift-U. It might help us. Control-Shift-U. And then if I type in 0D, you know, 0A 09 0A. These are used for various functions like character turn and backspace, and a perfect example of a tricky ASCII character. It's found in 05. Inquiry character. In other words, we cannot simply paste the character into our terminal when trying to use it. To type raw ASCII into your terminal, first press Ctrl-Shift-U and then the hex number like 05, and then press Enter to confirm the ASCII. Okay. Ctrl-Shift-U 05. That's not what. I was hoping maybe it was like some weird terminal thing. Yeah. So how from hex? Okay. But you're not helping. Align tools, maybe? Wow, just a lot of lines. So let's try this online converter and see what we get. We want 0D, 0A, 09, 0A. R R R R R R R R or I don't think that's what we want to be using, but again, one man. Seven two five C 725C 725C. So I'm thinking it's 72 and 5C. When we look that up here, I don't know why I struggle with this so much. But 72 and then 5C. Oh, it's in there somewhere. And I'm just going to use Python to quickly print out a 64 character string. Uh, print A 164. What? That's right. Oh, I probably need to do that within the quotes. All right. So now we have 64 A's. That means whatever we put at the end of it should start triggering what we want. Then our stack 3, paste our 64 A's, /n /r /t /n/t/n. $, $r, $/t /n, $/t $/n. $, quote, /r /n/t/n. We just did this yesterday. Aristotle helped me. You had the answer yesterday. The lag's probably so bad, you're probably like 10 minutes in the past. Is it possible we need to do /x /v /x 0a /x 09 /x 0a? Seeing the 0 gives, no, that's probably 30, right? It's 61, 30, 78. Let's see, what was 30? Zero? Oh, because I put the actual address in. C program /x escapes unnoted. Let's just do it quick. Okay. In C, X followed by the hexadecimal digits represent the hexadecimal escape. So how come when I did it, I didn't like that? Hmm. Can we just do that? Shoot. Paste that. If we do a /x 0D 0A 090A. No. Hey. I wish somebody /x 0D 0A 090A. It's gonna drive me mad. 2772. Which one's 27? Quill. Hmm. Oh, I want to 64 A's. Start executing there. How come we can't just try the quote, $/n /t/n/r? 5C 6E 5C 74 5C 2 bytes /x, and then that might want to just work. Right. For example, single quotation marks might be expressed as that, since writing that is not acceptable. That's not only one. Let's just say exploit. It says you want to show 8 digits, zeros, prefix. I'm struggling on the first one already. Do we have? Ooh, we do have. No, we don't. Restart, stack 0, reboot. Hoping we might be able to find it in the history. Oh, it might be in the history here. No. Uh-oh. At this again. Oh. Release my mouse, computer. Hmm. Oh, thank God. All right, you made it out of that. Let's leave that alone. History is not going to help us. Stack trace. We're going to want. I don't know why it's not executing properly. The environment variable one yesterday made sense because you can just use shell, but this one's not making as much. Not. Let's reread the code. Maybe that will give us a better understanding again. Yeah, trying. Yeah. Dope. Buffer 64. Pointer. Volume function pointer at %p new line. Flush standard out. Load this .fp. GDB. Let's try that against this. You can go ahead and say run. Paste in that. And it just exits. Run. Paste. Slash x. 0D. 0A. 09. 0A. Whoa. Okay. That's interesting. It did some stuff. What is going on here? Okay, we hit the segfault. Calling function pointer at this address. 39, 30, 61, 30, 64, 30, 78, 5C. We need this to get us to a different address. Why is it so long? Stack 3 stopped. Cannot access memory address. Yeah. Has this been working and I'm just missing something? Besides the ending in this? Slash X. And we'll start with 0A, 09, 0A, 0D. So it executes the first one, or is interpreting it the way we want for the first one. Hmm. Not helpful with these pointers. If locals fp print the function is calling at %p / n, else it's unmodified. So we're getting called here. This is equal to null. We're overwriting that. Two commands cannot be loaded in, run get missing to know why. Right. Congratulations, you finished the level 8. Void complete level. Break. Is there a find complete level? There is no find command. Help. Help. Breakpoints. What if I put a breakpoint on complete level? But why is that the address? The aim is to change the content of change me variable to 0D, 0A, 09, 0A, void 0, 61, A1. Is this still the right aim? We're, because it looks like we're just trying to get this to run, right? But I don't see where it's called. It's just calling function pointer at that, and then it print. Okay. We have to tell it to call this by figuring out the function address. And that pointer is what we're given to put in from the buffer. That's a weird way of doing that. So this is the address we have to get to get it to run, I think. So we run, input our A's. Can we do something like A1 / X06 / X40. I saw something. Segfault. Calling function pointer at that. how do we get there instead of the address we actually want? The probably should write down what that breakpoint is before I forget it. Put that in our notes. $64,6 and 6. That doesn't sound right. So it's only 3 characters. So that means 64,6,161. Ack. 64 at so it's at ack and then 161, which is not even a real thing. Okay. Run. Paste. Dang it. Trying to get to. Okay, yeah, it is only 3. 4006 A1. 4006 A1. Echo X 4006 A1. Write that into stack 3. Still nothing. Okay. Break. Clear level. Okay. Run a setting /x A1/x 06/x 40. What is going on? 4, 48, 120. 92. Hmm. This can't be right. There's the heading. There's no way to do the acknowledge. Some will. No. The quote. No, they look like it. A1. That's 6. 40. It's working at the same spot. Slightly different spot. Hmm. Transform the symbol there. I want to see where it says. Oh, it? Okay. It's completely reversed. So something like that, you know? Getting closer into the range. All right. What does this equate to? Okay. So now I do x slash. Where is it? Slash x. Put the x at the end. Do I just need to do that? Getting closer. We have to find out where that function is. Clear. Look. Complete level. Wait. 4D. Okay, does it change each time? 4D, no, 06, 9D. Maybe it does. Break, complete level. Okay, those are two different locations. Let's try this one now. So, slash 40 0 69, nice deep. Number 0, 06, 9D. It's completely reversed. So this needs to be 9D, 06 stays there, 4D, 40, right? I'm going crazy, aren't I? It's not. Is this what we have to do it? Am I doing it? Am I like doubling up on the hex for some reason? /x 9d Do we just have to use Python to try this? /x 9d /x 06 /x 40. All right. Now if we do our A's times 64 plus that. So if we take this Python command and type it into stack trace 3, I don't know. Okay. It's probably because Python's able to actually print the character that will do it. We can't actually type it. And that was the issue I was having yesterday trying to understand this better. Just couldn't connect the dots. Do I dare try another one? We'll take a look. Let's see what stack 4 is. If it's too much, then we'll just stop. Nope. Sorry. So there. And there we go. Just want to see if we. All right. Stack 4 takes a look at what can happen when you can overwrite the saved instruction pointer. Standard buffer overflow. Hence, the saved instruction pointer is not necessarily directly after the end of the variable allocations. Things like compiler padding can increase the size. Did you know some architectures may not save the return address on the stack in all cases? GDB supports run my file to any direct input from my file into the program. Okay, so we might be able to use our Python thing if we're overflowing stuff. All right. Phoenix stack 4. The aim is to execute the function complete level by modifying the saved return address and pointing it to the complete level function. Here's our joke. Why are the apple and orange all alone? Because banana split. That's... Yep. Got me. Yeah, right. Let's take a look at our code here. Welcome to level name. Complete the level. Congratulations. We have our start level function. And here's our main. Main creates the banner, then it starts the level, start level, our buffer, our return. Return is the built-in return address. Printf, and we'll be returning to %p return. So I think it's similar to what we were doing with stack 3. So we'll do GDB, stack 4. And we can go ahead ranked complete level. This one we're going for 4006 1D. Ranked built in trade press. No executable in file now. Your simple file. Run to direct input from my file into the program. All right, let's just go ahead and run this and see. Holding the program. We'll be returning to 4006 8D. So that's the return address. Is it going to be the same each time? 4006 8D. All right. Let's use our Python and see if it just works out the gate. Something tells me it won't. But I'm a gambling man. Fact. Link register. Holds the address for the return to your subroutine call complete. IBM power architecture, blah, blah, blah. So we want to find out if we can overwrite this address. Because it's void pointer let. And then we set what ret is. Are we able to collect that? Whoever does specifics. Okay. How big is our buffer? It's still 64. We're overriding the pointer here, supposedly. Let's just put 164. Now we're altering it with the A's. That's not enough. So we have to find out how many A's this actually needs in order to get up to where the pointer is. 164 is enough, so let's just try 100. Okay. That worked. Let's try 90. We just start touching it. So 95. We're pushing it. That's kind of funny. But okay, 96. So 96 A's. We change our pointer. We want to get to this, right? 4006 1D. Instead of 90. It's selection 4006 1D. Can I just have Python print that 96 times? So we start with 40 06 slash x1d. Is that correct? 4006 1D. Okay, I have it backwards. We can get rid of that padding. Let's try 1D. And try 40 here. Oh, did I forget? Okay. We might be doing just a little too much. Still too much. Still too much? Okay. $40.06 MD. What if we just say 30 and we'll just plus that last one? Let's reverse this again. Quote A times, should have been 64, but we'll put 94, plus the address we actually want. Close. 89. One more down. One less character. So 88. Boom. We got it. All right. So 88 characters to get to the return address to overwrite that pointer with the address we wanted, which was complete the level. Whew. Okay. I think with that, we're going to go ahead and call it there. Stream seems to be still a little choppy, but let me go ahead and close out and say thanks everyone for hanging out. Sorry, stream was a bit rough. Hopefully, I can get my internet fixed soon and we'll have a more stable connection. But in the meantime, make sure to check out my YouTube for VODs. Check out my Twitter. You'll usually get updates of when I'm streaming. I'm going to be aiming for 11 to 1 or 2 every weekday, Monday to Friday, Eastern Standard Time. And yeah, hope everyone has a great day. Thanks for hanging out, and hopefully you learned something. See you guys tomorrow. Bye.